In this video, I will show you how to find limits such as this. Let f be the function given by f of x equals 2x times e to the 2x. Find the limit as x approaches negative infinity of f of x, and find the limit as x approaches positive infinity of f of x. Let's start with the limit as x approaches negative infinity. I'm going to show you how to do this problem two different ways. First, I'm going to show you how to do it using techniques that we learned in Unit 1. Then, I'm going to show you how to do the same problem using derivatives and something called L'Hopital's rule, which we learned in Unit 4. So, if you're watching this video while you're still in Unit 1, the first method is going to be the one you're going to want to pay attention to. But if you are reviewing for the AP exam, you might want to use the more advanced method involving derivatives and L'Hopital's rule. In Unit 1, we learned an acronym called FEPL. FEPL stands for factorial, exponential, polynomial, and logarithmic. We can use FEPL when x is approaching positive infinity or negative infinity. It ranks the functions in order of how fast they grow as x is approaching infinity. The functions towards the top grow faster, and the ones toward the bottom grow slower. We can view f of x as a polynomial function times an exponential function. To use FEPL, we need to rewrite this as a fraction. So I'm going to drop the exponential part down to the denominator and write it as e to the negative 2x power. So now we have this. Imagine what happens to the numerator as x approaches negative infinity. So you can kind of think of this as 2 times negative infinity. 2 times a very, very negative number is still a very, very negative number. So as x approaches negative infinity, 2x approaches negative infinity. What about the denominator? You should be thinking something like e to the negative 2 times negative infinity. A negative times a negative is a positive. So this would be like e to the positive infinity. But e to the infinity power is just infinity. So as x approaches negative infinity, the denominator is approaching infinity. So here's where FEPL comes in. The numerator is a very simple polynomial expression, while the denominator is an exponential expression. Both of these are approaching some type of infinity, but they are not approaching infinity at the same rate. Exponential is higher on the list, and polynomial is lower. This reminds us that the denominator is going to be growing faster, while the numerator is growing slower. Because the denominator is growing faster compared to the numerator, it means that the magnitude of the denominator is getting bigger and bigger and bigger compared to the magnitude of the numerator. So the overall value of the fraction is getting closer and closer and closer to 0. So that's the limit. So that's how you can find the limit using only skills from Unit 1. Now I'm going to jump ahead to Unit 4 and show you how to find the same limit using derivatives and L'Hopital's rule. First of all, L'Hopital's rule can only be used when your expression is approaching infinity over infinity or 0 over 0. We found that our function, when written as a fraction, is approaching negative infinity over positive infinity. That counts as infinity over infinity, so we can use L'Hopital's rule. L'Hopital's rule says that the limit of f over g will equal the limit of f prime over g prime. In other words, we can take the derivative of the numerator and the denominator without changing the limit. So let's take the derivative of the numerator and the denominator and find the limit of that. By the way, in order to use L'Hopital's rule, you have to show these arrows like I did. Because you're not allowed to use L'Hopital's rule, unless the numerator and denominator are approaching infinity, or they can both be approaching 0. But you have to show it with arrows like this. This is mandatory. So the derivative of 2x is just 2. And this is a memorized rule. The derivative of e to the something is still e to the something. So when you take the derivative of an exponential expression, it doesn't change except for the fact that you have to do the chain rule. Because we have a function inside of a function, we then have to multiply by the derivative of the inner function. So the derivative of negative 2x is negative 2, so we will have to multiply by that. I'm noticing that these 2's will cancel out, so I think I'm going to go ahead and do that. So now we have this. Let's think about what's happening to the value of this fraction as x approaches negative infinity. Of course, the numerator is a constant, so that is just going to stay 1. What about the denominator? So this is what I'm thinking. I've got this negative sign out in the front, and I've got e to the negative 2x, but the x is approaching negative infinity. So I'm going to temporarily think negative 2 times negative infinity. That's just going to be positive infinity. If I take a very negative number and then multiply it by negative 2, I'm going to get a very, very big positive number. So basically I have negative e to the infinity power. E to the infinity power is just infinity, but with the negative sign in front, I have negative infinity. But what happens to the overall value of the fraction if the numerator is a constant while the denominator is getting more and more and more negative? Imagine 1 over negative 10, 1 over negative 100, 1 over negative 1,000, 1 over negative 1,000,000, 1 over negative 1,000,000,000. What is happening to the value of that fraction? Well, it is getting closer and closer and closer to 0. So that is the limit. We still need to talk about the limit as x approaches positive infinity, but this is super easy. If x is approaching infinity, then that means that 2 times x is also approaching infinity, and e to the 2x. This is like e to the infinity. So that's approaching infinity. So basically we are looking at infinity times infinity. Guess what that is? You guessed it, that's infinity. Or we can say that the limit does not exist. Here's a common mistake that I need you to avoid. You are not allowed to put an equal sign right here. You can't say that a limit equals infinity. If you put that, you will lose a point on the AP exam. You can't say equals and then say does not exist. That doesn't even make grammatical sense. So I would use the word is. So we can say that the limit of this function is infinity or does not exist. Just to be clear, I would put either one of these, but not both. My personal preference is does not exist.